You're driving to your sister's house when all of a sudden the sky changes. The cool weather becomes scorching hot in a matter of minutes. People who were going for casual autumn strolls have now taken off their jackets and are sweating. People who were planning on going for a weekend ski trip have canceled their plans at the last minute to head to the beach. It was sunset, but the sky has become as bright as day. You fish out your sunglasses and continue driving. Nothing seems normal, but people don't seem to care. You put on the radio and hear everyone panicking about the sun. Nothing is cohesive. They're jumbling up their words and saying a gazillion things at the same time. You take out your phone and see what's happening on social media, and it's all the same thing. Nothing is comprehensible. It's just people talking about how the sun is getting closer to the earth. Footsteps are clacking along a quiet hallway. A man dressed in a sharp suit is making his way to one of the most important meetings of his life. Adam walks through the meeting room while everyone is waiting to hear what he has to say. As the head astrophysicist, it's Adam's responsibility to figure out what is happening and not let the public know what's going on. Otherwise, the whole world will succumb to panic and mass hysteria, which won't be good. He takes a seat at the head of the table while everyone waits for what he has to say. The room is tense and no one is saying a word. He takes off his glasses and places them on the table. Everyone is watching his every move. He takes a few files out of his folder and starts reading. His voice can command a room. My fellow colleagues, I'm afraid the worst has fallen on us. After countless hours of consistent observation and analysis, we have discovered that a piece of the sun has abandoned its orbit and it's making its way toward us. We still don't know which part of the sun, but we know that once it strikes us, we may not have an Earth to call home any longer. The tension in the room is palpable. Everyone looks at each other confused. Adam answers as many questions as he can, but he himself doesn't even have some of the answers. In a matter of minutes, the press leaks some voice recording of Adam's speech, and the world goes berserk. Back to you. You just heard a snippet from Adam's speech and aren't too convinced of its validity. Even though the sky is getting brighter by the second, there's still no reason to panic. You continue driving, and suddenly you sense an intense vibration. Your car lifts off the ground and the windows shatter. You get out and duck for cover. You saw a comet-like object strike down in the middle of nowhere, miles away. More of these objects look like they're heading toward the ground. You start your car and drive off, trying to find a place to hide. Ashes start covering the sky, which makes it even hotter than it already is. The earth is scorching. Meanwhile, traffic is piling up for people who want to escape but don't have any real place to hide. You eventually abandon your car and go on foot, trying to find a place to cool down and get away from the sun's rays. Even though ash is covering the sky, the sun is still blasting through it. You head to the woods and find a cave to cool down in. It's still hot, but at least you can calm down and figure out your next move from there. You get out your phone and try to see if there's any news updates on what's happening, but nothing seems to be updating. You keep refreshing it, but nothing works. Suddenly, you hear some people getting closer, and they order you to step outside of the cave. Adam is with the top scientists in the world, trying to figure out a solution. Everyone is presenting him with solutions, but in the end, none of them are achievable. They've spent hours in the office, but with each passing minute, the sun is getting stronger and the sky is getting brighter. It feels like nothing can be done until Adam has an aha moment. He calls for everyone's attention and asks for the extra people who are not contributing to leave the room. He mentions that they need to launch a rocket into space that can divert the large mass heading toward the Earth before it breaches the atmosphere. They only have a few hours before the sky becomes completely dangerous and unsuitable for flying. As for now, all flights around the world have been canceled. There is only a small window of opportunity to get this rocket out there and save the world. Adam summons the best engineers he can find to adjust the rocket and the astronauts who will volunteer for the mission. They go into quick basic training and start planning for the next steps. After many briefings, they're ready, but they only have one shot at diverting the large object. The astronauts are ready and begin to enter the rocket. Suddenly, you pop up out of nowhere, dressed in a spacesuit. You're one of the prominent astronauts for the mission. Those people who found you in the cave were from NASA, trying to recruit you for the mission. You meet with Adam, and he quickly briefs you about your role. Because the mission is very last minute, there wasn't even time for Adam to sit with you and give you the proper training or brief. You enter the rocket and take your seat. The engineers and scientists gather around to make sure that everything is in order before takeoff. The large object is getting closer, and if the rocket is delayed, then it'll melt when it reaches the final part of the mission. You're strapped in and the rocket starts rattling. All systems are in order. 3, 2, 1, blast off. The rocket picks up and shoots into the sky. There are extra layers of visor shield protection, since it feels like you're getting closer to the sun. After a few minutes, the rocket leaves the Earth's atmosphere and is at the forefront of the large object. The rocket suspends itself in a certain strategic position, waiting for the right time to swat the object out of the Earth's trajectory. Meanwhile, everyone back on Earth is hiding in bunkers when the loose debris strikes. A cleanup team will be ready to get rid of the space rocks that will be scorching hot. The bunkers are equipped with food, water, and electricity in case they have to remain underground for a while. Only a few minutes left until the moment comes. You press a button and get ready to deploy a large spike that's as long as the Statue of Liberty. The spike is kept on a stand that's attached to the rocket. It will fire the spike like a bow and arrow and shoot it straight through the large object, breaking it before it melts. There's less than 1 minute before impact. The arrow is stretched and released. The tip of the arrow has a titanium drill that will continue drilling through the object as soon as it hits. The arrow is released and shoots through space, breaking little pieces of space objects along the way. As it speeds through, it finally hits the large object and drills through it. But nothing seems to be happening. The drill is barely getting through the center. Luckily, Adam had already thought of a backup plan. The rocket, still suspended in its spot, fires a laser where the spike is to speed things up. The laser starts melting through to get to the core. The object is getting closer and is speeding up. The object still hasn't broken into pieces yet. Less than 2 minutes until impact, and everyone is running out of options. Adam has one last trick up his sleeve. He orders everyone to evacuate the rocket and move to the backup pods. He wants to put the rocket on a straight collision course with the large object. There's too much confusion. Everyone, including you, quickly heads to the pods and ejects to a safe distance. These pods won't float around in space since they have pressurized air that allows the pods to move in whatever direction the driver wants. Everyone shoots out of the rocket while it goes full speed at the object. They're both going, heading for each other at full speed. There are only a few seconds until impact. The whole world is watching. This rocket is now the only hope there is to save everyone on Earth. The rocket starts melting before impact, and suddenly, a large shockwave ripples through the sky. The rocket was able to break the large object into many pieces. The problem now is the smaller debris falling onto Earth. But since everyone is in bunkers, they're safe. Adam and his colleagues celebrate. You and the rest of the astronauts are safe and make it safely back to Earth. The next phase for everyone on Earth is to rebuild everything that was destroyed. People will have to start everything from scratch, but this is only the beginning of a new chapter in life.
Is it possible for a planet to have not one, not two, but many suns? Let's imagine what would happen to us if the sun suddenly decided to break into a bunch of small stars. During the search for Earth-like planets throughout the universe, scientists have discovered that systems of 2 or even 3 stars are not actually that rare. Many of them even have planets in their habitable zones. Almost half of these planets could contain life. Can't wait to ask these guys about the sunsets. Scientists even suggest that our sun wasn't always lonely. It could have had a companion star called Nemesis. They've noticed that mass extinctions on Earth occur every 27 million years. It's like a cycle. So they turn to the stars to find out what the reason might be. And then they assumed that it was a star that left our sun a long time ago, but it still affects us. Nemesis could be located about 1.5 light years from us. It may not sound like a lot, but it's actually almost 9 trillion miles. That's going to be a fun car trip, 50 million years long. Anyway, every time Nemesis passes its orbit, it can affect the Oort cloud. The Oort cloud is an area surrounding our solar system in which comets are formed. Its existence hasn't yet been proven, but scientists are pretty sure about it. So, comets form inside this cloud and then relocate to our solar system. Even being very far away, the second star in the system can have a great influence on it. But what about systems with 4 or even more stars? Is it even possible? Actually, yeah. But the more celestial bodies you add to the system, the more difficult it becomes. The orbits grow unstable. It's going to be as chaotic as can be. In stellar mechanics, it's called the three-body problem. It says that it's very difficult to predict the orbits of bodies in such systems. In most cases, they turn out to be very random and unique. Isaac Newton was the first to have noticed it. He tried to apply his gravitational discoveries to the Earth, the Moon, and the Sun. He found himself with quite a struggle. It wasn't easy to understand how 3 stellar objects orbit so stably around each other. And that's just a planet and a satellite. How about including several stars? I wouldn't envy those who'll have to calculate all this. Oh, right, it's me. Anyway, we know that triple star systems are ridiculously chaotic. But what about systems with more stars? They're very, very rare. In 2021, NASA discovered a star system of as many as 6 stars. That's just crazy. Of course, there are no planets in it, but who knows? Maybe one day we'll find such a system too. In such worlds, the gravity dance is very complex. It takes very specific conditions to hold everything together. It's like walking on a tightrope over an abyss. With all this in mind, let's try to imagine what would happen if the sun suddenly turned into several small stars. Oh, we're going to need a very detailed simulation. No, probably even a dozen simulations to make this thing work, because otherwise, we'd only have a few options. Option 1. We divide the sun into 5 to 10 tiny suns. Now we'll scatter these guys not far from each other. They'll destroy our system in a couple of hours. Yeah. All star systems, including ours, are in constant motion across the universe. So, they'll crash into each other almost immediately. This collision will lead to the creation of a supernova. Our system will turn into a beautiful, colorful nebula. For us, it will happen in just a couple of minutes. We won't even have time to feel anything. And all the planets in the X solar system will immediately turn into sparkling space dust. But it's not the best option for us, right? Let's see if it can go any other way. Option 2. Since they can't be located so close to each other, let's try to set them as far away as possible. And in this case, they'll just leave. Bye-bye. Their gravitational force is too weak to hold everything together. The little suns will simply leave the solar system, flying into space in random directions. After that, the rest of the planets will descend from their orbits, including poor little us, of course. We'll become a so-called rogue planet. At first, we won't even realize that the planet has gone out of orbit, and we won't have time to do anything before it gets incredibly cold. What a sad and poetic end. In general, none of these outcomes sounds very fun. Oh, alright, we still have the last option. Our main problem is that we make each of these little stars the same mass. But just take a look at all these multi-star systems that we've already discovered. You'll see that none of them look like a bunch of glowing balls together. Instead, there are a couple of large stars there, and the rest, the small ones, are orbiting around them. So how about 2 large stars and 2 small ones? What will the Earth look like then? Well, its orbit will become terribly unstable. We'll shake back and forth. Wouldn't recommend it, honestly. We know what this can lead to because, and that's just crazy, this has already happened to us once. Yes, about 70,000 years ago, a lone star visited our solar system. It was a red dwarf called Scholz. A red dwarf is a very small and cold star, if you count 14,000 degrees Fahrenheit as cold, of course. But it's considered the weakest and coldest type of star, so it probably didn't look that big and bright in the sky. At that time, our ancestors, Homo sapiens, were already there living their lives. And can you imagine? They saw another star in the sky approaching the sun. I wonder what that looked like. And then, Scholz bypassed the sun and flew somewhere further to surf space. You weren't expecting some kind of disaster, were you? If it had happened, you wouldn't have had a chance to watch this video right now. But from this story, we can see what happens to the Earth during such stellar events. At that time, a huge amount of volcanic activity unfolded on our planet. We also got some meteor showers that almost wiped us out. Our ancestors sure had it rough. Something similar will happen on our hypothetical planet with 4 suns, but on a much greater scale. Constant volcanic activity, earthquakes, and tsunamis. Brr. In addition, the length of a day will change, as well as the length of all seasons, and a year as a whole. They won't be stable anymore due to the regular changes in gravitation. In other words, you'll never know when to expect an annual winter or hot summer. And when we are precisely in the middle between 2 stars, there won't be any nights at all. They'll illuminate both parts of our planet, and we'll have to sleep in bright sunlight. And if you think this is a bad thing, keep in mind that we'll also be attacked by much more ultraviolet rays and solar winds because of our 4 suns. Their color will also change. They'll become red dwarfs, looking distinctly orange-scarlet in the sky. We'll also get many more solar eclipses, except instead of the moon, the sun would be eclipsed by another sun. It would probably just get a little darker. To be honest, it's unlikely that anything would survive on Earth after all this. I mean, it is possible, but please run 100 simulations yourself if you want to make sure. But theoretically, we could survive in a simple binary star system. For example, in one that consists of 2 stars close to each other. Each of them would have to be 2 times smaller than our sun. That would be the perfect scenario. And it's quite possible in the future. NASA is currently working on a plan to relocate our descendants to Proxima Centauri b. That's a planet near the closest star system to our sun, Alpha Centauri. And who knows, maybe one day in the future, we'll really move there. Then we'll see what it's like to live with several suns. What would happen to us and our planet if it became as big as the sun? The diameter of the Earth is 8,000 miles. Crossing it is like driving back and forth across the USA 3 times. That doesn't sound like much, right? Well, how about repeating this journey 305 more times? Just imagine the gas expenses. This is the diameter of the sun, about 865,000 miles. Compared to our Earth, the sun is unimaginably huge. So what will happen to us if we catch up with it? There are 4 possible scenarios, depending on what we mean when we say the size of the sun. Scenario 1. The Earth becomes as large as the sun, but its mass remains the same. A colossal planet with the mass of a teeny tiny Earth. First, say bye-bye to gravity. The more massive the planet, the stronger its gravity is, and vice versa. Such a lightweight planet simply wouldn't be able to attract anything to itself. Gravity creates all the heavy substances. Everything, from pebbles to entire continents, is held thanks to it. I believe you've already guessed what would happen without it. We'd all turn into dust particles. Yes, the Earth simply becomes a dust cloud. Oh, and to add fuel to the fire, the gravities of other planets stretch us to the sides, leaving no chance to collect our planet back together again. This scenario doesn't look very good, does it? By the way, even if the Earth somehow remained a planet, life couldn't have originated on it in these conditions. There would have been a considerable distance between the center of the Earth and its surface. And remember, the planet's mass is minimal, so no gravity. It just wouldn't be able to hold the atmosphere. And without the atmosphere, living organisms cannot develop. Not like it would have mattered. The Earth now is a cloud anyway. So now this cloud, weighing about 10 times heavier than Jupiter, is gathering in space. As a result, it collapses and turns into a star. Say hi to the new sun. Scenario 2. This works both as a separate scenario and as a result of the previous one. The Earth becomes as large as the sun and gets its mass. Now we have 2 suns. We become a so-called binary star system. You know what that means? It's time to destroy our entire solar system. Imagine having 2 centers of mass in one system. The planet's orbits become unstable, perturbed by such a sudden change. Once they get closer to our ex-Earth, they collapse immediately, either from tidal forces or the ex-Earth's impact. Yes, even gas giants. Looking at you, Jupiter. Do you know which one survives and finally gets its revenge on us? Pluto. It would probably be the last remaining X-planet in the entire system. It's too far away to notice any changes, except for an increase in the mass of the center of the system. So Pluto's orbit comes closer to our 2-star system, and that's it. The Earth and the Sun would have to accept that Pluto would be their only friend now. The protoplanetary disk that formed our system billions of years ago doesn't exist anymore, so no more planets can be created in our system. That's all well and good, but what about the Earth itself? What would life be like? Let's see. The nights and days now last longer because of the increase in the Earth's rotation time. There is probably a significant temperature drop in the North and South poles. Even on our current small planet, they get sunlight scarcely. So if the Earth's size increased, the area of the poles receiving sunlight would decrease even more. On a positive note, there's a lot more space now. No more overpopulation. The planet's size is so huge that it would take you years to get from one point to another. Yeah, if you think about it, we'd probably be very lonely there. But hey, who knows? Maybe rockets would become our primary means of transportation. Yeah, that would have been cool. There are many vast uncharted areas that no human ever saw or visited. We also wouldn't know about the existence of many different civilizations and tribes. Centuries pass, and many of us go away without ever meeting other people or learning about them. And that's if we can walk at all. Our bones cannot support our weight with such a considerable gravity, and our hearts have to work twice as hard to keep us alive. The birds can't fly anymore. Nothing can, precisely. All the existing trees fall down, and the new ones grow very close to the earth, like grass. Talking about the trees, how is our ecosystem doing? Well, not good. If we don't appreciate the environment on our small Earth right now, imagine what would happen if we had such a massive space at our disposal. I even assume that our tons of garbage would have overpowered even those endless supplies of trees and clean water that we would have in our new large home. Our machines and robots have to be huge to do at least something now. That's because even ordinary farms now are the size of the US states. I also assume that it would be much darker than we're used to. The Earth is so small now. Imagine what would happen when our planet becomes the size of the sun itself. Less sunlight means that we'd probably need an artificial sun. Also, the temperature differences on the planet's surface would be huge. If you're surprised, you probably underestimated the size of the sun. It's almost 110 times larger than the Earth. Our new Earth's equator equals our current Earth's 35 equators. Oh, and remember Pluto? Well, it's our only moon now. The first one would have probably crashed into us a long time ago, making us share the fate of the dinosaurs. In that case, all the water would likely evaporate from our planet. Anyway, there are thousands of bad possibilities, but let's just move on and focus on something good. Scenario 3. Same thing, but the Earth retains its density. Now this one is interesting. We're no longer a planet. We're a star now. In fact, we became even more massive than the Sun. Our planet now has a 3.9 solar mass because we need to balance our low density somehow. In short, it would be almost the same as in scenario 2, but with more interesting long-term consequences. Since our Earth became 4 times as massive as the Sun, it would have burned its fuel quicker. Then it would evolve, and depending on the mass of its core, it either becomes a supernova or just blows off its outer layers to form a planetary nebula. If it goes supernova, the Sun that was so close to us blasts, and now there is just our ex-Earth, a lonely ball with a teeny tiny diameter of 12.5 miles. We're a neutron star. That is, a star made of degenerate neutron matter. That thing is ultra dense and spins very quickly, so you'd better stay away from it. If the Earth becomes a nebula, the Sun collects all the dust and adds it to its mass. Now we have a slightly more massive Sun and a white dwarf. The time passes, and Grandpa Sun lives out his life. It becomes a red giant after depleting the hydrogen in its core. It starts expanding and leaves its material, mostly hydrogen, on the white dwarf. That's us. When the matter reaches high enough temperatures and pressures, nuclear fusion happens. We become a nova. Yay, we're a star again. A lonely one, but a star nevertheless. So what happens next? You see, a star is a battle of opposing forces. One of them is gravity, which tries in every possible way to compress the lead into a small ball as much as possible. The second is a pile of fuel in the star's core, which, while burning, forms tons of energy and substantial hot temperatures. As long as these forces are in balance, the star lives. But when the star's fuel runs out, the star cools down. The pressure inside it drops. This means gravity has won. It squeezes the star with all its might, and as a result, the star goes, hooray! In just 15 seconds, the brightest light you've ever seen in your life flashes, and our ex-Earth goes supernova, leaving a stunning nebula behind. Anyway, don't worry. It's actually impossible for a rocky planet to be the size of the Sun. Only other stars can be that large. But wait, why is our Earth so small while the other planets are enormous? Do they just keep growing, or do they stop at some point? The more mass you add, the more compression you get. As planets become more massive, the gravitational compression increases. They stop growing when their mass reaches roughly 1.7 times that of Jupiter, or 540 masses of the Earth. After that, adding more mass to a planet will make it smaller, because the compression becomes stronger. In other words, our little thought experiment is impossible.